Okay, so for question 15, the percent of people who are left-handed is 15%. The car manufacturer wants to have left-handed people participate in their study, so they send out 500 requests for left-handed people. Find the probability of obtaining a sample of 500 people in which between 13 and 19% say they're left-handed. So now we're doing between 13 and 19%. And remember from the previous problem, we have the SE of 0.016. So because we're looking for in between, we have to find two separate z-scores. So the first one is 0.13 minus the 0.15 divided by 0.016. And then we have 0.19 minus 0.15 divided by 0.016. So when we put that in the calculator, we get parenthesis 0.13 minus 0.15 close parenthesis divided by 0.016. For 13, we get negative 1.25, negative 1.25. And for 19, we get parenthesis 0.19 minus 0.15 close parenthesis divided by 0.016, and we get 2.5. Okay, so we have our z-scores. And we'll draw a picture. Negative 1.25 would be 1.25 centiviations to the left, and 2.50 would be 2.5 centiviations to the right. We shade everything in between. And then we're going to look up each one separately. So let's look up negative 1.25 first. So let's look up negative 1.25 first. So we're going to look up negative 1.25. So we have negative 1.2. We're going to find the 5, match them up. Negative 1.25. And that gives us 0.1056. Remember, the table always tells us to the left. 0.1056. Okay, not shaded. Then we're going to look up positive 2.50. So go to the positive table. We're going to look up 2.50, 2.50, 2.50. So we go to the positive table. We're going to look for 2.5 and 0. We're going to match those up. 2.5 and 0, and that gives us 0.9938. 0.9938, which is shaded and not shaded, 0.9938. So to find the in-between, we subtract them. 99.38% minus 10.56%. Put that in the calculator. 99.38 minus 10.56. And you get 88.82. 88.82%. 88.82%. Now, to check that, there's a couple of different ways. Number one, your calculator can do less than, it can do more than, but in the way we've been doing it doesn't really do in between, but we can do less than twice. But in order to do it with the z, one proportion z, we need the fractions where it came from. So for this problem, we have 0.13. What would the fraction be? Well, the denominator is 500. So 500 times 0.13, 0.13 times the sample size 500, you get the numerator of 65. So the numerator would be your x, 65, the denominator would be n, and then for 0.19, again, the denominator is the sample size 500. So 0.19 times 500, 0.19 times 500, and that would get you 95. So in the calculator, using the one proportion z, we're going to find the first one less than, and we're going to find the second one less than, then we'll subtract like we do by hand. So we go to the calculator, stat, over to tests, number 5, the p is 0.15, the first fraction is 65 over 500. So x is 65 and it's 500. And remember, for in between, we're going to do less than twice. We find the less than, go to calculator draw, and that gives us 0.1052. 0.1052. And then we'll do the other one less than, 95 out of 500. So that's stat over to test, number 5. P is 0.15. X would be 95. Again, it comes from the fraction, 95 out of 500. Choose less than, go to calculator draw, and the P is 0.9939. 0.9939. And then we would take these two numbers and subtract. So 9939 minus the 1052. Put that in the calculator. 9939 minus the 1052. And you get 8887. 8887%, which is very close to what we got, 82%. So that's one way to check it. The other way to check it, because we have the z-scores starting and ending, we could use normal CDF. So normal CDF would be where the z-score begins, negative 1.25, comma, where it ends, 2.50, mean of 0, standard deviation of 1. And again, it's kind of optional to check it this way, but that's another way to check it. To do that, you do second vars, number 2, normal CDF, number 2, normal CDF. Again, where does it begin? Negative 1.25 would be our lower. Upper would be 2.5. And then the mean is 0, standard deviation is 1. Or if you have the form of the calculator, you would put negative 1.25, comma, which is above the 7, 2.5, comma, 0, comma, 1. And you get 8881, 8881, all of which giving you very close all three ways. Okay, so I'm going to write it using our one we got by hand and put there is a 88.82% chance of randomly selecting 500 people in which between 13 and 19% are left-handed. Again, there is a 88.82% chance of randomly selecting 500 people in which between 13 and 19% are left-handed.